So last week we have started this probabilities, right? Sets and probabilities, and we have seen two formulas for probabilities: NE over NS. And second one was union rule. Union F is equal PE plus PF minus E and F. Okay, we had these two formulas. For example, here, this one is about what? Two dice. When you roll two dice, there are how many? 36 possibilities. Okay, 36. And for example, find the probability of first die shows 2, or sum is between what? 7 and 6. Okay, if you have such questions, then you have to use what? Union rule. So first is 2 plus sum is between 6 and 7 minus the intersection. First 2 and at the same time sum is between 6 and 7. Okay, first 2. First 2 is here. 2, 1, 2, 2, 2, 3. Okay, this row. How many elements? 6 out of 36. Plus sum between 7 and 8 here. Sum, if you add them, you get 6. This one, you get 7. 4 plus 2 gives you 6. 5 plus 2 gives you 7. Okay, the blue ones are the sum 6 and 7. Okay, so how many? 11 out of 36. And at the same time, first is 2 and sum is between 7 and 6 and 7. We have two elements. Okay, these two, 2 4 and 2 5. We are counting them twice, so you have to subtract them. So it's equal to 15 out of 36. And then you can use your calculator. It's approximately 0.42. So we have seen such problems last week. Okay, now we start new formula. So next one, find the probability that when two paired dice are rolled, the sum is less than 11. So here you can count. So it's about sum less than 11. Okay, we have to find this one. But sometimes it is easier to find the opposite of that event. For example, sum 11 here, how many? Okay, this one. Sum less than 11, here we have 33 of them. Okay, you can count 33 elements, or instead of that, you can use what? Complement rule. We have this rule: PE plus PE complement is equal to 1. Okay, formula number 3. This one we call complement rule. So from this, you can generate two more formulas. If you want, you can find PE from here. That's equal 1 minus PE complement. Or if you find PE complement, then it's equal to 1 minus PE. Okay, you can generate two formulas. So here, instead of finding this, instead of finding sum less than 11, we can use this formula. So it's equal 1 minus complement of E means the opposite. So the event is less than 10, right? Sum is less than 10. The opposite will be sum is not less than 10. Okay, you just put not there. So that means sum is greater or equal 11. Not less than 11 means greater or equal 11. So that's equal 1 minus. Now you see, instead of counting 33 elements, okay, change color. Okay, instead of counting the 33 elements, we can just count these 3. Okay, we have, yes, Jahangir.
Mm,
36. But you get same result. That's equal 33 out of 36. Understand? This one we call complement rule. Okay, next formula. So this one we call odds in favor. So it is just the ratio of PE and PE complement. For example, if the probability of snow tomorrow is 3 over 10, probability of this event snow tomorrow is 3 over 10. Find the odds in favor of snow tomorrow. So we have to find what? PE over PE complement. So we can find PE complement using complement rule. 1 minus PE, that's equal 1 minus 3 over 10 equals 7 over 10. This is the probability of no snow tomorrow. So if you find odds in favor, it's equals 3 over 10 to 7 over 10. That's equal 3 divided by 7, or you can write 3 to 7. This is odds in favor of snow tomorrow. So odds in favor of snow tomorrow is 3 to 7. That means there is 30% chance of snow tomorrow and 70% chance of no snow tomorrow. Okay, instead of saying these two, we can just give it in this way. Okay, this is just ratio. So next we have the opposite. Here the probability is given. Okay, probability is given. You have to find what? The odds in favor. This formula, if odds in favor is given and you have to find the probabilities, then you can use these two formulas. For example, if the odds that the package will be delivered on time are 17 to 3, so delivered on time and not delivered on time, the ratio is equal 17 to 3. This is given. Find the probability that package will not be delivered on time. So we have to find what? The probability that package will not be delivered on time. So this one. This is M, this one is N. If you substitute, you get 3 divided by 17 plus 3, that's equal 3 over 20. Or you can write it as 0.15. So the probability of the package will not be delivered on time is 0.15, or there is 15% chance. Okay, 15% of the cases the package will not be delivered on time. And if you want, you can find the probability of the package will be delivered on time also. How to find? From here you can use complement rule, or if you want you can use this formula. So 1 minus 0.15 is 0.85. The probability that package will be delivered on time is 0.85. Next. Next one is conditional probability. Okay, this is the probability of event E given that, given what? Event F. Okay, F is given, we can find the probability of E. For example, second is red, first is heart. So we have cards. We have these cards. Okay, we want to take out heart. So here, the first one is heart. Now we are picking two cards. Okay, so first card is heart. Okay, we throw it. Now, how many cards left? 51. Now, what's the probability of choosing red card now? Understand? The first one is heart. I take it away. Okay, I just throw it. Now, how many? We have 51 cards left. And what is the probability of choosing red card? Okay, if I pick one card, what's the probability of that card is red? So 51 cards left, and how many red cards? There was 26 total, but I take out heart, which is also red. So how many left? 25 red cards left. Okay, so the probability is 25 over 51. That is conditional probability. The condition is given. Okay, example. And we have this formula also. This is same thing. Okay, the formula for conditional probability was like this. If you find this intersection from here, you will get this formula. Okay, we call it product rule. This formula is obtained from the formula of conditional probability. Okay, so we call this decision tree. So, okay, wait, let me show you some examples from the book. Okay, so where is chapter 7? So, okay, 7.5. Let's see some examples. Formula for the conditional probability. Okay, if two cards are drawn without replacement from an ordinary deck, find the probabilities of the following results. So you see there is word without replacement. Okay, so there is two different kinds here. We have with replacement and without replacement. Without replacement, and let's write here with replacement. So the formula is EF equal E and F divided by PF. This is the formula. So number 9. The second is heart, given that, so probability of second card is heart, given that first is heart. Okay, so if there's word given, that means you have to put this symbol. Okay, this means given. Okay, this means given. This is and. This one is or. So given that first is heart. So here we have 52 cards. I take out what? Heart. So first one is heart, and after choosing first card, it says without replacement. That means you don't put it back, okay? You just throw it. Now, how many cards left? 51. And how many hearts left? There was 13, but I take out one heart, so 12 hearts left, and 51 cards left. Okay, so the probability of picking second card heart is 12 over 51. If with replacement, that means you pick a card that's heart, then you replace it back, you put it back, okay? Then you choose another one. Then here it will be same as, so second heart, first heart, okay? It will be same as P heart, okay? Same as the probability of picking heart, because we are replacing it back. After you choose heart, you put it back, so nothing changes. You still have 52 cards and 13 hearts. Okay, that is with replacement. Number 10. The second is black. Second black. Given that, so we put this symbol. First is spade. So now we take out spade. So where's spade? Yeah. So we have 52 cards. First card we pick is spade. Okay, without replacement means you just throw it. So how many cards left? 51. So denominator will be 51. What's the probability of choosing black card now? How many blacks left? 25. Because there was 26 black, but spade is also black. Therefore, if you take out this card, how many? 25 black cards left. Number 10. If with replacement, okay, after you choose first card, you replace it back and choose again. Then nothing changes. You still, so it's still same with P black. Okay, there are 26 blacks, 52 cards, because it is with replacement. You put it back. So number 11. The second is face. Second is face. Given that first is jack. Okay, so first one is jack here. Okay, so I pick a card that is jack. Without replacement means you just throw it. So how many cards left? 51. What is the probability of choosing face card now? How many face left? There was 12 face cards, but jack is also face card. So if you take out, how many? 11 face cards left. Understand?
Yes.
Next. And with replacement, it will be nothing changes. Okay, it is same with P face. So it is 11 over 51. The second is ace, given that first is not ace. Probability of second is ace, given that first is ace. So here we have ace. Okay, ace means this card. Okay, tuз, ace. So you pick a card which is not ace. Okay, first one is not ace. Okay, not ace. Okay, the first card is not ace. Let's assume it is 4. Okay, it is not ace. So you just throw the card which is not ace. So how many cards left? 51. How many ace left? Still 4. Because the first card wasn't ace. Okay, so it doesn't affect the number of aces here. So still we have 4 aces, but we have 51 cards because we throw 1 card out. Okay, therefore it is equal 4 divided by 51. Here with replacement, so you pick a card which is not ace, then you put it back. Now we want to pick second card. What's the probability of ace? That's equal same as p ace. That means 4 out of 52 because you replace it back. Therefore, still we have 52 cards. Do you have any questions? If no, then let's move to let's see number 15 and 16 first. Okay, then we will see number 13 and 14. Okay, so number 15. 2 black cards are drawn. P, black, and black. Okay, black and black. Now, okay, now we are picking 2 cards. Okay, we are picking 2 cards. What's the probability of both of them are black? Okay, what's the probability of getting 2 black cards? You see, it is not given. There is no word given, so it is not conditional probability. It is black and black. So, but we can use this conditional probability formula. Okay, let's change it. From here, we find this intersection. So that means, so P, E, and F is equal to PF times what? PE given ZF. Okay, from the conditional formula, we find this intersection. So then it is equal P black times P black when black. If you use this formula, you get this one. So first one is P black. So we have 52 cards. What is the probability of picking black card? How many blacks? 26 out of 52. Then next one. So we pick already. Okay, here we have picked black card. So it is without replacement, so you just throw it. Now what is the probability of the second is also black? Okay, so how many blacks left? 25. Total how many? 51 left. How we can know how many hearts and etc. in a deck? Okay, that one you have to see, you have to watch my last lecture. Okay, I have explained everything about cards. There are 52 cards in total, 26 red, 26 black, 13 hearts, 13 diamonds, 13 spades and clubs. Then there was 12 face cards, 4 aces, 4 twos, 4 threes, 4 fours, and so on. 4 jacks, 4 queens. Just watch the previous lecture, okay? Number 15 done. Then 16. Okay, this one you calculate using your calculator. So 25 times 26 times 25 divided by 51 and 52. So it's approximately 0.245. 16. Two hearts are drawn. P heart and heart. Okay, two hearts. So again we use this conditional probability formula. P heart times heart when first is heart. So first one is probability of choosing heart. What's the probability of choosing heart? How many hearts? We have 52 cards and we have 13 hearts. Okay, the first one. Then next, now we choose heart from here. Let's say here. Okay, we choose heart. So first card is heart, 5 heart. Without replacement, that means you just throw it. Now, what is the probability of picking heart again? So how many hearts left? 12 out of 51. Okay, because we take out one card. So total number of cards has decreased by 1, and it was heart. Therefore, total number of hearts also decreased by 1. Therefore, it is 12 over 51. Then again, you use your calculator. So 13 times 12 divided by 52 and divided by 51. It's approximately 0.0588. Now let's see what happens if it is with replacement. That means black and black. If you use this formula, you get P black times P black when it's black. But it is same, the second one, it is with replacement. So after you pick a black card, so if you take black card, after you pick this, you put it back. Okay, and choose again. It is with replacement. Therefore, it will be same as P black. So, so the probability of choosing black card is 26 out of 52. But after you choose black card, what you do? You replace it back. With replacement means you put it back. Okay, then you choose another one. What's the probability of choosing black card? Nothing changed here. Okay, number of cards still 52. Number of blacks still 26. So you get 0.25. 16. Okay, usually we call them independent events. So next, the heart and heart. Oops. Okay, the first the probability of second event doesn't affected by probability of first event. Then we call them independent events. So it is 13 out of 52 times 13 out of 52. You get 0.0 so 625 0625 I think. Let me check. 13 times. Okay, correct. Do you have any questions about number 15 and 16? If no, then let me clean this and explain number 13 and 14. Number 13, probability of a jack and 10. Jack and 10. Okay, getting jack and 10. If it says first jack and second 10, that is different. But it says jack and 10. So the order doesn't matter here. So you may have two cases. The first, okay, you may have first jack, second 10. Okay, first one is jack and second is 10. Or First one is 10 and second is jack. Understand? You may have two cases here. You may get jack 10 or 10 jack. The first card is jack, second is 10, or first 10, second jack. You have to consider these two cases. Okay, so you have to add them. So first one, jack and 10. So we use this formula P10 P jack when first one is 10. P jack plus 10 when it is jack. Okay, you separate this into two like this. For each, you use this formula, product rule. Okay, then you find, so probability of choosing 10. How many 10s we have? We have 4 out of 52. Okay, 4 10s here. Now we take out 10. What's the probability of choosing jack? So if you take out 10, okay, if you take out 10, how many cards left? 51. How many jacks left? Still 4, because first one was 10. So then P jack. How many jacks? We have 4 out of 52. And how many? So now we take out jack. Okay, so you take out jack. What's the probability of choosing 10? We have still 4 10s, but we have 51 cards left. So 4 times 4 is 16. So 32 divided by 52 times 51. That's equal to, so 32 divided by 52 divided by 51. That's approximately 0.012. Okay, if with replacement, you write 52, 452, okay, until here. Okay, this one will be the same, but then it is with the replacement, so you replace it back, nothing changed. Number of cards and number of jacks and number of tens will be the same. So you get this value, 32 out of 52 square. That's 0.0118. Next. Number 14. Probability of choosing ace and 4. So ace and 4. That means we have two cases again. Can be first ace. So first ace and second is 4, or first one is 4 and second is ace. Okay, so you use this product rule again. P4 times P is when the first card is 4 plus P is times probability of choosing 4 when first card is ace. Okay, so number of ace, number of 4 is same as this one, so you can copy this one. Okay, you get same results as previous question. Do you have any questions? This is 13. So number 14, also you get same result with the previous one. Answer for 13. So 16, 32 divided by 52 divided by 51, 0.012. Look, for number 13, you don't add denominators. Okay, 2/4 plus 3/4. It's not like 2 plus 3 and 4 plus 4. You don't add denominators. Okay, you add only numerators. Therefore, it is 0.012. Okay. Okay, so let's go back to our slide. So here, okay, this is the slide. So for example, probability of choosing red and black. Okay, this is first choice, second choice. So probability of choosing red and black. So it can be this red black or black red. Okay, so if they say like this, you have to add these two. Okay, you find product of this one times this plus this one times this one. That gives you the probability of choosing red and black. If you pick two cards, the probability of choosing red and black is equal to 2652 times 2651 plus 2652 times 2651. Okay, if they say the probability of choosing, so we pick two cards, what is the probability of choosing first red, second black? Then it will be only this part. Okay, here red, first red, second black. But if it says red and black, that means we have two cases, two conditions: first red, second black, or first black, second red. Therefore, you have to consider both cases and you have to add them. So I think that's it. Okay, here. Okay, so for independent events, for example, with replacement, okay, if you replace it back, nothing changes. The number of cards, number of hearts, everything will be the same. Then it is independent event. So instead of finding this conditional one, you can find this. For example, P heart when first is heart. If it is with replacement, that means you pick a heart, then you put it back. Now we want to choose second one. What's the probability of choosing heart? So number of hearts isn't affected, okay, from the first one because we replace it back. So still we have 13 out of 52 cards.